Hello sir, myself Neil Nakia 23CS040, and today I will going to discuss about Google Cloud Tensor Processing Unit, in short TPU, Tensor Processing Units. Okay, so our agenda will be introduction to TPUs, what are the evolutions, their architecture and design, TPU types and generation, their hardware specification, then comparison of TPU, GPU and CPU, what are the key features of TPU, then setting up TPUs on Google Cloud, then challenges and limitations, cost and pricing of TPU because of course they are not free, comparison of TPU generation, best practices for using TPUs, then what are the future trends, and at last the summary. So what is TPUs? TPU are basically chips which are developed by the Google, which are used to train AI models and machine. They are basically used for machine learning. The purpose is for TPU is they are crucial for large-scale models. They are first announced in 2015 and every generation is offering enhanced capabilities with the latest technology. These are the evolution of TPUs. The first generation only focuses on accelerating inference tasks. Inference basically means once the AI model is trained, then the model has to be predict the future activities, their predictions, and the emotions. Next generation designed for both training and inference, which and third generation which launched in 2018 are added cooling, liquid cooling enhancing performance means more performance, more heat will be generated and cooling will be needed. The fourth generation is optimized for large scale deep learning models means very big and large models can be trained by fourth generation. TPU architecture and design. TPUs are custom-designed ASICs (application-specific integrated circuit) created by Google. Key architecture component: matrix multiplication multiply unit (MXU). TPU are best optimized for matrix multiplication because basically matrix multiplication are very complex task and TPU can optimize it in very careful way. Contains thousands of MSE. MSE means multiply accumulate units. Highly efficient at performing large matrix multiplication, which I just informed you. Vector processing unit executes known matrix operations such as element-wise additions, activation, and other tensor process operation. Means they are used in basic operation also. Works alongside the MXU to handle nonlinear transformation in neural networks. Scalar processing unit handles scalar operations such as control, flow, branching, and basic arithmetic. Means if TPU can handle the large matrix multiplication, then of course it can control the basic arithmetic units. Manages operations that are not efficiently performed by vector or matrix units. High bandwidth memory. Integrated HBM to ensure rapid access to large-scale data. Means very high bandwidth helps the TPU to access large-scale data from its memory very quickly. TPU have multiple HBM modules offering terabytes per second bandwidth. And the bandwidth of TPUs are in terms of terabytes per second. Of course, they are crucial for deep learning models because AI model need to access large data in very less time. Now next, TPU types and generation. First is HTPU, designed for lower power IoT device, means lower power like light sensors and motion sensors are used. They use HTPU, Cloud TPU version 2, balanced performance for training medium scale models. Cloud TPU version 3, liquid cooling for enhanced performance. And version 4, high efficiency design for complex models. Means from 1 to 4, the efficiency and performance is increasing. TPU hardware specifications. Version 2 has 8 GB of high bandwidth, 180 teraflops per core. Similarly, version 3 has 16 HBM and 420 teraflops per core, and version 4 has 32 HBM, 1000 teraflops per core. Okay, these are the comparison of TPU, GPU, and CPU. In terms of performance, TPU are optimized for machine learning, GPU are for graphics and versatile use, CPU are for general purpose. First is TPU is cheaper than GPU and CPU comes at moderate price. Memory, TPU contains high bandwidth memory, CPU contains GDDR and CPU contains DDR. And TPU uses for to train AI models, GPU used for graphics, machine learning like video editing, photo editing, and CPU used for general computing for day-to-day tasks. Now, TPU version 1. Okay. Initially used for inference in applications like Google Search and Alphabet. Their performance is we have already discussed performance and memory in last slide. Availability, okay. They are not available to every individual. TPU version 2. They contain air-cooled unit, Google Cloud first publicly available version of version. Okay, so TPU version 2 is available for every public. Now version 3. It contains water cooled to enable higher clock speed. Water cooling is used in version 3 to use in large AI models. Version 4. Okay, version 4 performance has 1000 plus teraflops and designed for TPU for sustainable for state-of-the-art research. Okay, now let's see what is TPU ports. Yes, what is TPU port? A collection of interconnected TPU devices that work together as a single powerful unit. Hence, when so many more than one TPUs are interconnected, and they work as one powerful unit, they are called TPU port. Supports distributed training for massive models because means when massive model are trained, the task is distributed among all the TPUs. How TPU accelerate machine learning? We discussed that matrix multiplication acceleration. They are used to design matrix multiplication at higher speed compared to that CPU and GPU. Low latency and high throughput means the latency is less. Means when you give any command and computer inputs the command, the time gap between these two is very less and the output frequency is too high. Memory bandwidth. They have HBM which reduces the time on fetching the data. How to set up TPU on Google Cloud. Create a Google Cloud project, enable billing and API access, select TPU node, choose the any version. Now configure virtual machine instance. Set up a virtual machine and connect the TPU. Deploy the code. Upload and TensorFlow code on TPU. Challenges of using TPU. Limited framework support. Mainly optimized for TensorFlow. PyTorch support is limited. Okay, the support is limited, not optimized for code adaptation. They require code changes to take full advantage of TPU architecture. Okay, so the code which uses in TPU are different from the normal code. Scalability issues. Large models need careful planning to utilize TPU ports and means to use TPU ports they are very complex. Normal human being cannot handle this. Okay. TPU support for different machine learning frameworks. Tensor best supported with native TPU API. JX. A Nobly-inspired framework that scales efficiently on TPUs used for large-scale research models. AlphaFold is the best example. PyTorch. Limited TPU support with torch_XML library. TPU in using phase transformers. Easily train and fine-tune transformer model like BOT and GPT on TPUs using phase integration. Now TPU uses case in AI. Google. Okay, so Google are using TPU for search and ads. Basically, search and ads are machines which learn from our search activities and then recommend the same thing to us. Google Photos. Uh, Google Photos uses AI in such a way that they know that which are the persons which are close to us and suggest the same photos on our homepage and also make the videos every week for us. Okay, YouTube recommendation. So what we search, they are analyzed by AI and then recommended same to us. Language translation. Okay, these are the pricing for TPUs. Version 5 P version for one chip to use 1 hour, it is $4.2. For commitment of 1 year, $2.94, and for commitment of 3 years, the price is less, that is $1.89. Similarly, for version 5e. What are the future of these TPUs? Next generation TPU, Google is working on version 5 and focusing on improved scalability and energy efficiency. Of course, when one version is launched, the company will work on next generation to enhance their capabilities. Integration new frameworks. New frameworks will be added of machine learning, AI hardware innovation. New hardware parameters like neuromorphic computing and quantum accelerators for future memory workloads. Okay. So what is the summary of TPUs? They are basically TPUs are used for machine learning and they will be very useful once they are at their peak performance. We know that AI is as much as dangerous and as much as useful for us. If we use in limited amount, it will be great. Now, every companies are working on robots, their AI models like ChatGPT and all. And there will be less need of human being. TPUs they are trained on basis of TPUs means without TPUs they are nothing. So these are the summary of our ROG PPT. So thank you sir, and this was my presentation. Thank you. Have a good day.